In this video, I'd like to talk about checkpoint 6. Checkpoint 6 is in section 6.2.6 and is problem 109. In this video, I'm going to talk about the materials problem number 4. So if you go to the checkpoint materials and scroll, by the way, some really good detailed explanations in these examples. I would strongly encourage you to read them over carefully and maybe work the problems as you go for yourself. But I'd like to talk about problem number 4, which is this pattern right here. So as you can see, we have the pattern. In figure number 1, there are 1, 2, 3, 4, 5 tiles. In figure number 2, you can see figure number 1 plus 3 additional tiles. And then if you look at figure 3, you can see we've added 3 more. So we have 3 additional tiles. Figure 2 then has 8. 3 additional tiles. Figure 3 has 11, and so on. We can work backwards as well to figure out what figure 0 would have. If we take 3 tiles away, figure 0 should have 2 tiles. If that's difficult to see what those 2 tiles would be, since we're adding these 3 tiles in each figure, imagine removing these 3 tiles. Actually, let's make it more visually obvious. Imagine removing these 3 tiles. These then would be the only 2 tiles left. So figure 0 would look something like this. So to make the graph, figure 0 has 2 tiles. Figure 1 has 5 tiles. Figure 2 has 8. Figure 3 has 11. Figure 4 has 14, and so on. Drawing the line that connects those points would look something like that. All that's left at this point is the equation. Well, we know from when we were still working on this in class together that the equation takes on the form y equals something times x plus something else. This is where we start, or how many tiles are in figure 0, and this is what it is growing by. This is the growth. In this case, we're growing by 3 tiles, and you can see that visually. If we go over to the next figure, we go up 3 tiles. So our growth is 3, and we started figure 0 with 2 tiles. So the equation is y equals 3x plus 2. The equation, the graph, and a table. Notice the checkpoint instructions say if you start with a tile figure, you need to make the other 3. If you start with, say, an equation, like in number 6, you need to make the other representations. Important note, though, since there are many possible patterns, it is not necessary to create a tile pattern. So you don't have to come up with what these tile patterns would actually look like. If you have questions or if you need help, please let me know. Send me an email, hop in my office hours.